he has also good experience in programming and related to remanufacturing or reconfiguration systems are there. So please, Manjit,
स्प्लिट के साथ में
kindly
ए
introduce
बनी है.
Professor Faisal.
Good afternoon, everyone. Am I audible, Deepak sir?
Yes, Manjeet, please
Yeah,
carry on.
perfect.
Yes, sir. On the behalf of organizing committee for this FDP program, we would like to welcome Professor Fazil Hassan and express our gratitude towards him for sharing his knowledge, experience, and wisdom with all of us today. The broad area of his talk would be around reconfigurable manufacturing system, a step towards sustainable manufacturing. Professor Fazil Hassan is a professor in Department of Mechanical Engineering, JH College of Engineering and Technology, Aligarh Muslim University, Aligarh. He did his PhD in the area of reconfigurable manufacturing system from IIT Roorkee. He has joined as faculty in the Department of Mechanical Engineering AMU in 2003. He is presently engaged in teaching and his area of interest includes manufacturing systems, human factors, and operating management. He has published papers in various international SCI index journals. Now, with these words, we would request Professor Fazil Hassan to kindly take the session so that we all can benefit from his lecture. Please, sir.
Thank you, Manjeet. And first of all, I would like to extend my gratitude to the organizers of this FDP for inviting me to deliver my talk on reconfigurable manufacturing system. So am I audible to all of you?
Yes, sir.
Yes, sir, you are audible.
Okay. So let me share my presentation directly. So I think my presentation is visible.
It is visible, sir.
Yes, sir, it is visible.
Okay. So what I would like to discuss with the audience of this program is something about a manufacturing system. To be more specific, something related to what we call as a reconfigurable manufacturing system, and how this reconfigurable manufacturing system is basically aiding towards the concept of Industry 4. So this will be the broad theme of my talk today. So if you just see the agenda of my talk, I will be focusing on first just to give you a brief introduction about the various industrial evolutions which have been taken place in the past. And recently we are talking of the concept of Industry 4. What do we mean by it? And how come the manufacturing system is an important ingredient of this Industry 4.0? Then we are talking of sustainability. So the term green is important as far as the sustainable manufacturing technology is concerned. So something about the green technology and how this manufacturing system is basically aids in the implementation of the concept of green technology. And finally, some introductory ideas about what the reconfigurable manufacturing system is all about. What are its components? How do we plan for implementing this reconfigurable manufacturing system? So this will be my broad agenda of the talk today. Now let us see what are the different events which are taking place around us. So if you see, what do we have right now? What we are trying to achieve is to reduce the time to market. That means what we want the product to be delivered very quickly to the end user. And simultaneous to this reduction in the time to market, what else do we require? We are focusing on the flexibility, or we are trying to make systems which are more flexible. Flexibility has many definitions, but rather what we are talking of today is flexibility simply means that what we intend to produce, that can be produced with the help of the infrastructure what we are having on the shop floor. So on one hand, we are focusing on reduction in the time to manufacture. On the other hand, we are trying to make our system more flexible so that they can incorporate the design and the manufacturing changes which are occurring in the market or in the product rather. And keeping these two things in mind, what we are trying to do, we are trying to boost the efficiency of our systems. So that is basically the scenario what we are witnessing today. Now, if we see the concept behind or the evolution behind Industry 4.0, if I just recall what has already been happened in the past and what is happening nowadays, like if I recall the first industrial revolution, so the basic philosophy behind the first industrial revolution is the introduction of mechanical production facilities with the help of water and steam power. So that was the first revolution which took place something in the year 1978. And with this, what people have created is the first, what we call as a mechanical loom. Now, when we talk of the second industrial revolution, so switching over from first to second, the basic difference between the two is that here we are moving towards the scientific school of thought, and these Taylor's principle, division of work, division of labor, they get into picture, and electrical energy is now available for the equipment and the machinery to function. So that revolution is basically termed as the second industrial revolution. So introduction of division of labor, of course, mass production with the help of electric energy. So the very first thing that is being created by keeping the idea of the second industrial revolution is a slaughterhouse which was established in the United States, Cincinnati, in somewhere around 1870. So here some scientific school of management coming into picture, which basically gives us the idea behind the division of labor and job specialization, mass production, and of course we are doing it with the help of electric power. Or no more steam is required, rather we are doing it with the help of electrical energy. Now, the third industrial revolution, it begins with the introduction of this microchips and the processors. So what happened, the first programmable logic controller was created or was designed and developed. And here what we are trying to do, the use of electronic and IT system that further automates the production. Now, automation means when we are basically, whenever we are involved in making same type of product in large volumes, we have what we are doing, we are repeating the process again and again. So whenever repetition of the same process is there, so the best way of doing this is to automate a system. So with the help of the creation of the microcontrollers, the research in the area of semiconductors, all these things, they are basically responsible for the third industrial revolution. Okay. Now, what we are talking of today is the fourth industrial revolution, which we generally termed as Industry 4.0. And why this is happening? Because nowadays what we are having a technology where we can store a large amount of data, and we can communicate or we can extract relevant information from this data, and we can access this data as per our need. So with the help of the creation of this type of infrastructure, what we call this system as a cyber physical system, because of the creation of cyber physical systems. This is basically the governing factor behind what we call as the fourth industrial revolution or the Industry 4.0. So this is what we are witnessing today. So all of us are using mobile phones, and you can see that how easily we can access, say, if some cameras are installed at our houses, then simply by using our mobile phones, we are seeing what is happening around my house when you are actually not present at your house. Rather, you are sitting in office and monitoring everything. So this is nothing but this is possible just because of the creation of cyber physical system, decrease in the size of the memory, more storage memory is available, and all these things are basically responsible for this kind of revolution. Now, if we see the complexity, of course, the first one is relatively simple system, but as we move from first to fourth, we see the complexity and the degree of complexity of the system increases. And this increases because of that fact that we have to integrate many things. If simply we are seeing or we are just watching the camera which is being installed in our houses, we are using so many subsystems within these two communications. We are accessing some space where the images are being stored or a video is being broadcast. So we are accessing this. And if we see the other end where the camera is installed, it is capturing something and delivering it to some space or some location, and from there we are extracting it. So the thing is that the complexity of such system is high as compared to the previous industrial revolutions. Now, if we see the concept behind Industry 4.2, it is particularly used across Europe and in the German manufacturing system initially. Other terms which we generally use for denoting Industry 4.0 are what we call as Internet of Things, or sometimes we call this as Internet of Everything or Industrial Internet. So all these things, they basically convey the same meaning, what we call as the concept or the idea behind Industry 4.0. So all these concepts emphasizes on all these concepts, the emphasis of all these concepts is on the traditional manufacturing and production methods are in the mode of digital transformation. So here what we are doing, we are slowly transforming our factories into a digital version of the same. Just to comprehend, you compare what we are doing in earlier manufacturing. We are having a piece of raw material and we are doing some subtractive manufacturing process where the unwanted material is being removed and we are getting the desired shape from that on that raw material. But today the concept is totally changed. We are capturing some images. We are converting these images into some digital format. Then we are feeding this image which we have captured or we have converted into digital format into what we call as a rapid prototyping or 3D manufacturing kind of thing. And then instead of subtractive, we are having additive manufacturing, where layer by layer deposition is being considered. So we don't have any wastage and we are getting a product out of it. So this is what we call as the digital transformation. So when we talk of Industry 4.0, these are some of the key enablers of Industry 4.2, what we call as sensors, computing power. All these terms are self-explanatory. The storage capacities, data analytics, network, internet speed, size of the storage devices. So there are so many things which basically which are the key enablers of what we call as Internet of Things, IoT technology, or what we call as the Industry 4.0. So these are some of the key enablers, and this picture basically it depicts that how these things are being integrated. So Bluetooth technology is one such concept of integration, which we are using in our day-to-day life. So these are basically the enablers, what we call as the concept behind Industry 4.0. Again, the same representation, what we have an industrial environment, we have certain inputs, we are getting some output. Of course, the basic objective is to reduce some kind of wastage or to optimize the energy which is being used within this system. And what we get is a product. And of course, the primary motive of manufacturing this product is to enhance its quality and to reduce its manufacturing costs so that we can attract more number of customers. And how these things are integrated? These things are integrated by a cloud, what we care as a cyber cloud, where all these storage, retrieval, input information processing, data analytics, all these things are happening within this cloud, what we call as a cyberspace. So the integration of all these things is possible, what we call as a cyberspace, or sometimes what we call as IoT technology. So we have an IoT technology where we can capture the data, and with the help of this data or with the help of data analytics, what we require at the present point of time, we can extract that information of this data so that we can take the action accordingly. Some data is useful for company X, might be some other form of data is useful for company Y. So the same data can be shared by the two companies, and every company is utilizing it in the same way. But the thing is, what is in common, that the integration of these two companies is via this cyberspace, what we call as a cyber physical system. So this is what we mean by a cyber physical system. So if we see here, what do we have? We have, when we talk of automation, so what we did, we replace our factories with the help with replace our factories by robots. The concept of dark factories was introduced. Why we call these as dark factories? Because when no manual interference is there, only machinery is responsible for carrying out the work. We don't require any illumination in that kind of room. So the concept of dark factories comes into picture. So what we did, we have replaced the manpower by a robot. But when we talk of the concept of industry 4.0, here the thing is that it is being replaced by a robot, but not necessarily the robot which is in our house. It can be outsourced to a foreign robot. So that is basically the transition of a conventional manufacturing, what we are having, or a few decades back, what we call as automation. But here again, automation is there, but that automation is being carried out not necessarily by a robotic system which we are having in-house, but rather we can take the help of any robot or any device which is situated remotely. So that is the primary difference between the manufacturing scenario what we are witnessing today. Now, if we see the building blocks of the concept of this industry 4.0. Industry 4.0 is, or 4.0, whatever you need to call it. So industry 4, the building blocks of this industry 4.0, these are some of the building blocks. What are these? Integration, Internet of Things, cyber security, augmented reality, sometimes we call this as virtual reality, big data analytics, automation and robotics, simulation. So these are a few of the blocks which I have shown here. And one of the block is basically what we call as a manufacturing systems. So in manufacturing, when we call this a manufacturing system, I'm dealing with both the kind of manufacturing system, which deals with additive manufacturing also, or subtractive manufacturing also. If we talk of the modern context, slowly we are switching over to additive, but sometimes conventional manufacturing can't be excluded. So we call that as a subtractive manufacturing. So one of the key block for industry 4.0 enabler is what we call as a manufacturing system. Now, when we talk of a sustainable technology, what do we mean? So although it is not just confined, whatever bullets I have written, the domain may be much more broader. But some of the things which we can think of when we talk of a technology, and before this technology, we have the word sustainable. What it means? It means environmental friendly technology. That means it should create minimum waste. It should be minimum as far as CO2 or carbon emission is concerned. It should not affect the environment in a negative way. Sometimes we say a sustainable technology is the one which conserve natural resources, dependency on renewable power, runs the gamut from generating power to non-toxic cleaning products. What product we are delivering, it must be non-toxic in the sense that when it comes for its disposal, it should be eco-friendly. So reduction of waste. Nowadays we are talking about loss of e-waste also. Okay, so this thing is that generating power to non-toxic cleaning products, technology that utilizes the energy provided by renewable energy sources. So we have seen how nowadays this solar power, the usage of solar power is being enhanced. Nowadays, perhaps these households, they are also switching over to the solar energy. And of course, the technology should be innovative and sustainable. Of course, so these are some of the key terms which comes into one's mind whenever we talk of a technology that is sustainable. Now, what we want to achieve with the help of this sustainable technology. So, or what we can think of, or what are the goals which we need to achieve if we go for this kind of technology. So, rethinking, if I give you an example, all of us are using emails. Sometimes what you will find in the mailboxes, when you are reading a particular mail, there is a tagline written that, is it really necessary to print this? So that is what we call as rethink. So think before printing it, because once you go for printing, there will be a creation of waste, usage of paper, usage of power, consumption of say electricity or whatever you want to call. So just think whether it is desirable to print it, or just reading it on the screen will serve the purpose. So this is what we mean by rethink. Recycling. So we need to produce products, or sometimes what we do is, nowadays it is very common that an old product is being taken back and it is being recycled in the refurbished form, or some of the components, they are being used somewhere else. So this is what we mean by recycling. An excellent example is what we call as recycling of waste paper. So many things one can make by recycling of this paper. Polyethylene bags, we are using this the concept of recycling. So that is basically the basic idea behind the recycling of products. Renewing. So instead of throwing it away, say for example in our computer systems, sometimes what happens, our system gets obsolete. So generally this obsolescence is sometimes due to the processor incapability or the storage incapability. So what we can do, instead of throwing it, you just renew it. One can install a new processor or a motherboard, or you can go for a better capacity hard drive. So this is what we mean by renewing. And of course, why we are doing all this? To reduce the waste, to utilize the energy, or to optimize the usage of energy. And of course, this all we can do at a reduced cost, because we are not throwing it and you are not buying it a new one. Simply we are doing it cost wise, we are carrying out this process in an economical way. And of course, these are the responsibility of one person's towards the environment also. So that is why these are the few goals which we generally think of whenever we talk of the concept behind green technology or sustainable technology. Now, when it comes to manufacturing systems, because the focus of my talk is today is on manufacturing system. So let us see what do we mean by a manufacturing system. So all of us are familiar with the concept of a manufacturing system. So for a very early, if we go by a very early definition of a manufacturing system, we call this as a black box. What this black box is, it is basically what is this black box is doing. we are having a raw material, and once a raw material is being entered into this black box, and this black box is having certain capabilities or certain, we can say, ingredients within it. And these ingredients are in the form of energy, equipment, tooling, fixture, manpower. And once a interaction of all these things are taking place within this black box, what we get is a product which is useful or readily used by the end user or by the society. And what else we get is something in the form of a scrap. So this is how we define a manufacturing system. So a manufacturing system, we can say, is an integration of equipment, tooling, fixture, labor, of course, equipped with some energy, where we can input some raw materials. Sometimes we call these as M's: money, material, manpower. So all these things will act as a raw material to this system. And finally, what we get is a product which is useful for the society or for an individual person. So manufacturing system is the framework within which the conversion of input into output occurs. So that is a very simple definition of what we call a manufacturing system. Of course, if we compare a manufacturing systems, then we have a lot of development. We have a manufacturing system where we can find a robotic arm just transferring one raw material or one semi-finished product from one machine to another. You may have seen some vehicles moving inside a manufacturing system, transporting one piece of equipment, one piece of semi-finished or the finished raw material to another machine. Sometimes you find some conveyor belt moving. So this is basically how the manufacturing system is being evolved. Okay. So but as far as the basic definition of a manufacturing system is concerned, we can define it in a very simple way, that this is simply the framework where we are converting some raw material into a product which is useful for the society or for an individual as well. So this is how we define. Now, sometimes we often get confused with a manufacturing system and a production system, and we uses both the terms simultaneously. That is, at one point of time, we are using a term manufacturing system, and at the other point of time, we are using the term production system. So there is a difference between the two. And just to have a very brief idea behind the differences, that whenever we are talking of a factory level, we call this as a manufacturing system. And whenever we are taking a holistic approach at the enterprise level, we call this as a production system. Or in a very simple words, we can say that manufacturing system is a subset of production system. So production system is whatever is happening on the shop floor. If you are having a lab, a manufacturing process lab or a production lab, so that is basically a manufacturing system. But if you see this as a department of mechanical engineering within which this lab is there, we call this as a production system. So that is the basic difference between a production system and a manufacturing system. So there are some technologies which aid or which act as an input to this manufacturing system. Some of these are automation and control technologies, material handling equipments, quality control systems. And this, on the other hand, if we talk of an enterprise level, there is a support system which basically constantly interacts with this manufacturing system. So manufacturing system is basically responsible for producing things, but how much to produce, who is going to decide this, or what will be the demand, or where we are going to ship this product. These are some of the decisions which are being taken at enterprise level. So that is the primary difference between a production system and a manufacturing system. Or we can say that the production system is a superset and a manufacturing system is a subset of this production system. So this is the difference between the two. Now, if we talk of sustainable manufacturing or green manufacturing or green technology, Just think of few phenomena or few products which are available before us or which we have witnessed with our eye. Concept of flying cars, though not a very realistic concept, but we have seen this concept in movies also, and lot of videos on social media you might have seen where a car is being converted into a flying car as per the need. Then few of the items which are available in our households, like sofa cum bed. So at times we are using this as a sofa, and at times we are using this as a bed. Food processor. Earlier you have a concept of grinder only, then mixer only, but nowadays we call this as a food processor. Is there any difference between the grinder or a mixer or a food processor? So just think, these are some of the products which are available before us, and we can think of what we are talking of. That is why we are calling this as a food processor, because we are calling this as a food processor because mixture is also a component of these food processor. Juicer is also a component of these food processor. Grinder is also a component of these food processor. If you are making a say what we call as a shake, milk shake or some mango shake, then that is also a kind of subcomponent of these food processor. So a single machine is basically catering multiple purpose, whether it is dry grinding, it is making of mango shake, it is wet grinding. So all these things are basically clubbed together, and a machine is being created, what we call as a food processor. Then slowly, if you see, we are moving towards framed structures. Earlier, what do we have? We have load-bearing walls. We are constructing houses, and we are basically construction is on load-bearing walls. But now, yes, am I audible? Is there any interruption?
No, sir, you are audible.
Okay. So slowly we are moving towards the design of the buildings in the form of framed structures. So earthquake resistant is one such feature of these systems, but there are so many other features also. If you want to change the interior look of your house, and if you are having a framed structure, you can renew this over a period of time. So you want your room to be much bigger, you remove the intermediate wall between the two rooms. So that can be done if you have a framed structure. You want to have a room converted into a washroom, that you can do if you are having a framed structure. So just these are the few things which we are seeing around us. Now, if we just implement this thing, like, can we think of a manufacturing system without any dedicated machine? That means what we are having today on our shop floor, that what we think of, that when we say that I am having a workshop, so what one get out of it, that you may be having a drill machine, you are having a lathe machine, you are having a milling or some welding equipments like that. But can you think of a workshop where we don't have any dedicated machine? That means what do we have in that kind of system? So instead of dedicated machine, if we carefully visualize the most conventional machines which are there on our shop floors, what it includes, the basic components of any machinery: we have drives, we have motors, we have flywheels, we have bed, we have carriage, we have a framed structure. So all these components are perhaps common to every machine. Okay, we are having job holding devices. So can we think of making a machine as per our need if we are having just these components, or we can assemble these components to create a machine for making a product X, and the same machine can be reassembled again for carrying out processes or somewhat different processes on product B? So this is the basic concept, what we call as the concept behind the reconfiguration. We are basically converting at one point of time, we are assembling these components to serve the purpose of lathe, then dismantling it and again assembling it to serve the purpose of a drill, say for example. So this is the basic philosophy behind reconfiguration. If we just compare this with the concept of the flying car, a car is being driven on the road, and say for example, if it is a flying car and it got struck into some jam or some other phenomena, then what it can it be converted into a flying car, so that this can be the time which is being wasted in this jam can be reduced or overcome. So this is the concept behind the reconfiguration. Here the car is being reconfigured into a flying car. Similarly, the sofa is being reconfigured into a bed, or a bed is reconfigured into a sofa. Okay. Similarly, for a food processor, at one point of time, we are using this food processor as a grinder. At another point of time, we are using the same food processor as a chopper, or as a as a device for making a milkshake, or as a juicer at another point of time. So this is the basic idea behind what we call as reconfiguration. That means at one point of time, we can convert the same machine as, say, a lathe, and another point of time, we can reassemble it in a different way, so that we can get, say, some other machine, say, for example, a shaper. The idea is somewhat similar to the concept of making toys out of blocks. So we have seen, or we have perhaps have already played with these types of Lego blocks, where we are constructing these or assembling these blocks over one another. At one point of time, a car is being created, and at another point of at another point of time, these blocks, they can be rearranged to create a house. So this is the basic concept behind reconfiguration. So if we see, the reconfigurability is a characteristic that can be changed by reconfiguration or by some adjustment, add-ons, manipulators, etc. The design is very simple. Like if we just compare the chairs with the earlier chairs which we are using in our house. Earlier chairs were fixed. You don't have any arrangement for adjusting the height or adjusting the back. But nowadays you have chairs where you can adjust the height depending upon the requirement of the table or the height of the person. And depending upon your comfort, you can adjust the backrest time. So a car, simply what we are doing, we are giving some flexibility to this chair so that it can be adjusted as per the requirement of any person. So that is the basic idea behind reconfigurability. So this static reconfigurability distinguishes between reconfiguration time and runtime. Now the thing is that when we talk of reconfiguration, converting a sofa into bed, we have to first analyze how much time it is taking. If the process of reassembling it in the shape of a sofa or in the shape of a bed is too high, then that reconfiguration is not sustainable. The reconfiguration process should be very fast and simple. So that is being worked upon. That though the idea is very old, but how quickly we are changing from one configuration to another. So a trade-off is to be done, where we can analyze that what is the reconfiguration time and how much we are losing or how much we are capable of reducing this reconfiguration time. Earlier, what do we have? We have the changeover time. So here we moving from one reconfiguration to another, we call as the reconfiguration time. So that reconfiguration time should be minimum, and the reconfiguration should be simple. Like if I say that you can adjust the chair by taking out 6 bolts and then moving the backrest and again putting on these 6 bolts again, then that is something which is taking a lot of time, and you will be going to avoid it. So rather, what do we have? We have a lever. You just push it back and you just leave the lever. So backrest, it's adjusted. Similar is the case with the height. We are having a lever. You just pull it down, you adjust the height, and you release the lever. So that the reconfiguration time is very low. So the thing is that whenever we talk of reconfigurability, we have to think that how we can reduce the switchover time. Now, this is another idea. If you wish, all of us might have seen these movie from Doom series. So that is basically based on the idea of reconfigurability. Lot of reconfiguration is taking place. The same bike, it can be used as an underwater vehicle. Then the same bike is being used as a flying bike. The same two-wheeler is reconfigured into a four-wheeler. So that is the basic idea behind reconfigurability. Now, there are two things. Some people might get confused with the reconfigurability and the flexibility. Is there any difference between the two? Now, if you see, what is the difference between the two? So just to explain the difference, I have put few pictures on this slide. Now, in these pictures, I am comparing three things, not only two, rather I am comparing three things. Now, we have wrenches. So these are the wrenches which we are using conventionally. So with the help of this wrench, if I am having a one, I have the option of opening of or putting up of nut and bolts of two sizes. One size is being determined at by this end, and another is being determined by this end. Now, say if I need to have a size which doesn't fit either on this and either on this, so what I need to purchase a new one so that it may be fitted onto the new size which is there before me. So I can buy a new one. So every wrench is basically, or a spanner is basically dedicated to open two sizes, one from this end and another from this end. So if I want to have a flexibility of 4, I need 2 wrenches. Okay. If I need to have a flexibility of 6, I need to have 3. Okay. Then sometimes in mechanic shop, you can even find one having 4 different sizes. Another crossbar is attached here, and 2 sizes are again on this crossbar. So that is how the evolution is taking place. So this is what we call as a dedicated system. So dedicated system means that a specific end is designed to open specific size or to put on size. But if you compare with this one, here what do we have? This is a wrench where we have an adjustable screw. So you can move this screw, rack and pinion type of arrangement is there. And you can have any size between the two extremities. One, when the jaw is very near or nearly close to each other, and when the two jaws are extreme apart. So this is the range which we can cater if we are having this type of wrench available. So this is what we call as flexibility. Any size between the two extremities, we can open with the help of this wrench, what we call as a flexible one. Now, if I give you a third concept, the third concept is that I don't have any wrench of this kind or any wrench of this type. Of course, if we compare the cost, then a single wrench is much lower in cost as compared to this one. Now, if I give you a third idea, the third idea that instead of having this one or this one, you have certain components. Like if I am having a bar with a handle, and these are the heads. Say if I want to open one size, I am having this head. So I remove this head, I fit on to the second head on this assembly, I may open or place a second size nut and bolt. Similarly, third and fourth. So as per our need, I can purchase only these heads, and rest of the bar, the connecting rod and the handle will serve the purpose. So here also, I'm talking of flexibility. But if I compare this one with this one, here we are having unlimited flexibility as far as the two extremities are concerned. But here the flexibility depends upon how much heads I am having. So this concept that how much heads I am having, this is basically the concept behind the reconfigurability. Or simply we can say that limited flexibility is termed as reconfigurability. Whenever we are talking of limited flexibility, so limited flexibility is synonymous to reconfiguration. So the thing is, a car can be, or a two-wheeler can be converted into anything. So when we say that this two-wheeler can be converted into anything, in a cycle also, a bus also, an aeroplane also, a helicopter also, a steamer also, this is what we call as flexibility. Anything which we can, this can be converted. But when we talk of some limited flexibility, this car is converted just into a flying car. That's all, nothing else. Not an underwater vehicle nor a two-wheeler. So this is what we call as a limited flexibility. So limited flexibility is the basic idea behind reconfiguration. Hope I would have communicated that what do we mean by reconfigurability. So this is the basic idea behind the reconfiguration. So when we talk of a manufacturing system, to be more specific, a reconfigurable manufacturing system, here the focus is on two things: reconfiguration in the functionality also, and reconfiguration in the capacity also. Because as far as the machine is concerned, machine provides me two things. One is the shape which we want, and on how many jobs I want this shape. So one is the capacity of the machine, and another is the feature which I am getting out from this machine. So when we talk of a reconfigurable manufacturing system, it must cater both. That means at one point of time, if you want the output of your machine to be 10 units per minute, it can give that. And if I want my output to be 20 units, so I can scale up my machine so that it can give me an output of 20 units per minute. So this is what we call as the reconfiguration in capacity. And when it comes to functionality, say if I want say thread, so I may use a lathe machine for threading. Okay, and if say I want a slot onto it, a keyway onto it, then the same machine can be reconverted into a planer or a shaper where I can cut this keyway. So whenever we talk of a reconfigurable manufacturing system, I need to have both the things into my system. That is the reconfiguration in terms of capacity and the reconfiguration in terms of functionality. Now, this I have already told you that if we just compare the flexibilities, because flexible manufacturing system is an older concept as compared to reconfigurable. Although if you think of this in terms of technology, then a flexible manufacturing system is much more advanced as compared to a reconfigurable manufacturing system. But if I see it on a time scale, then the development of flexible manufacturing system is much earlier as compared to reconfigurable manufacturing system. Because yeah, please. Yes, yes, somebody wants to communicate something. Okay. Okay. So the thing is that when it comes to flexibility, as I have told you that what we want in a reconfigurable manufacturing system, we are not talking of a flexibility or 100% flexibility. We are just talking of some limited flexibility. Now, this is basically a typical system which basically represents a flexible manufacturing system. So as I said, that the development of flexible manufacturing system is much earlier than the development of reconfigurable manufacturing system. Even nowadays, it's very hard to find any reconfigurable manufacturing system. Only people are developing prototype models of reconfigurable machine tools. and that too in the United States. We have a lab, and rest of the things are comparatively new and at a very early stage of research. So flexible manufacturing system, when we say a system is a flexible manufacturing system, what ideally it means? Ideally, it means that it can manufacture anything, independent of the process, independent of the features, independent of the material, independent of the volume. But it's very hard to achieve it. So the thing is that if we see, this is what an ideal flexible manufacturing system is. But some of the ingredients of or components of a flexible manufacturing system are the CNC machines. So because if we have these CNC machines, we can have the changeable program, that the operations which we want to perform, that are basically governed with the help of a program. So this program can be changed to incorporate the features which we required on our job if we are manufacturing it on a flexible manufacturing system. So we have some robotic arms, some automated guided vehicles, some CNC machines where we have a tool magazine and turret type of thing, and we have a central computer which is basically governing the working of all these machines, or the interaction between of one machine with the help with the other machine. So all these components are there when we talk of a flexible manufacturing system. Now, flexible manufacturing system, we can say a system that can manufacture anything. And as I told, that it's something very hard to achieve. So the thing is, what we talk of some limited flexibility. We don't want to have a system where we can have 100% flexibility, or rather I can say that, okay, my system is capable of producing type A, B, C, D, like that. So not A to Z, but simply we can focus on some limited domain. Say my system is capable of producing rotational parts. Any rotational part I can produce. Say my system is capable of producing just prismatic parts. So this is the idea behind reconfiguration. So instead of talking of unlimited flexibility, we are just talking of some limited flexibility. So why this limited flexibility arises? So to understand this concept, the key term which is being used is what we call as a responsiveness. Responsiveness here simply means that how quickly we are changing or we are switching from one system to another. So that is what we mean by responsiveness. And the current market scenario, the current phenomena which we are witnessing in our day-to-day life is a high degree of responsiveness. And why do we have this responsiveness? Because sometimes this responsiveness is due to the market changes which are happening. And why these market changes are happening? Because a product which I want is different from what you want. I want a car which is customized in my own way. Other person wants a car which is customized in his or her own way. I want a different design. Another person wants a different design. I want more head clearance. Another person wants more leg clearance. So a lot of customization is taking place. And the product life cycle nowadays is very limited. Slowly, every day we are getting a new model. You see how the automotive sector is being evolved. Scooters, geared vehicles, they are now obsolete. Earlier we have Bajaj, Priya, Vespa, all these type of scooters. Now we are having an entirely new segment of scooters. Similarly, you can see cars. In every month or in every 2 or 3 months, we are getting a new model of a particular car. So the thing is, we are basically moving at a very faster pace as far as the design considerations or the features are required. Every 2 or 3 months, you are having a new model of something. So the thing is that if we continue with the old system, old manufacturing system, and say my old manufacturing system is responsible for producing product A. Now, if I switch over to product B, is my manufacturing system capable of producing this B or not? So that is the thing, which is, if your system is capable, you say your system is responsive. Slowly we have shifted from A to B, and your system also changes from A to B. Okay, so that is the basic idea behind responsiveness, and some of the other factors which are responsible for this, the characteristic of responsiveness: customers order. Sometimes you are having very high orders. Like few days ago, I am listening to a news where the demand for these masks, they are reduced by 60%. Earlier, the demand is very high. Now, slowly it is reducing. Now, the company or the person who has set up a plant of manufacturing masks, he is witnessing a shortfall in the demand. What he will do? Switch over to some other one, switch over to some other design, switch over some new product. So this is what we mean by responsiveness. Sometimes governmental regulations, environmental laws are coming into picture. So how quickly we are responding to it. And sometimes because of system failure, we need to be much more responsive. And the key to success is nowadays only those companies are going to survive which are having a very high degree of responsiveness. We have seen the case study of Nokia. Few decades back, everyone is having a Nokia mobile phone, but nowadays you won't see any Nokia mobile phone. Nobody is having it, or a very limited number of limited population is having it. So that is just that Nokia is not responsive to what the market is being witnessed. So that is the reason behind reducing in the demand for Nokia products. Now, when we talk of the reconfiguration, so this is how one can explain. Like what we do, we develop a system for product A. So develop product A. So the thing is, this product is being developed. Then what we do, we build a system where we can produce this product A, and then we try to run this system, what we call as a ramp up. So we go for ramp up, and once this ramp up is ready, so what we can do, what we are doing in the past, that we are producing a same product A over a long period of time. So this is what is followed conventionally. There is no change in the design. The demand is almost the same, and this is the traditional way of manufacturing a system. Of course, from starting from the development till the product is ready, we call this as a system lead time. Okay, so this is how the things are happening. Now, if we see the modern scenario, what do we have? Initially, we start with product A. So we built a manufacturing system around product A. We go for ramp up and we start producing A. Now, when the production of A is taking place, we have a new product which comes into picture. Or we let us call this as a product B. Now, what we have to do, we have to produce this product A as well, because the demand is still there, but slowly we have to look what product B requirements are there. So the thing is, here, once this production is over, my system should be ready for producing this product B. So this is what we call as reconfiguration of the system. Now, instead of producing A, I am producing product B. So this is called the ramp up time. Then we will be having a phase where we are having product A also and product B also. So this ramp up is to accommodate this product B, not for changing from product A to product B. Simultaneously, now we are producing two products, that is both A and B together on the same system. So if my system is responsible, I can accommodate two. Now, as we move forward, say for example, product A becomes obsolete. Now, no more demand for product A is there, but there is a demand for another product, what we call as a product C. Then again, I need some reconfiguration, then again ramp up time. Now, with this ramp up time and reconfiguration, my system must be capable of producing product B and C. So product B and C. So this is the idea behind the reconfigurable manufacturing system. Or this is what we say, that the degree of responsiveness is high if my system is capable of accommodating these products over a period of time. So the change, and these are the products because we have a change in the design. Say, for example, we may have a product A still, but with certain design changes. Or if my system is not capable of this kind of changeover, then I will be losing the race with my competitors. So the idea behind reconfiguration is this, and to put this in words, we call this as exactly the functionality needed and exactly when it is needed. So these two things, they are being taken care of when we talk of a reconfigurable manufacturing system. Okay, so this is how it evolves. Like if I see it on a capacity functionality plot. So earlier, what do we have? We have a dedicated manufacturing line, product A, which is being produced in large quantities. So what happened? The capacity of such system is very high, very high. Same type of product is being produced over a long period of time. On the other hand, we have a flexible manufacturing system where we have multiple products. Any product can be manufactured. But if we see the capacity of such system is very low, they are very slow in operations. But when we talk of RMS, it evolves over a period of time. Slowly, initially the capacity is less, then I am accommodating another product B, I have increased its capacity. Then A becomes obsolete or A is being discarded, another product is being added, B and C, and my system works like this. So this is what we call as the evolving functionality and capacity. The functionality is also evolving as we are slowly moving from A to B, then from B to C, and maybe from C to D, like that. And that quantities which are being demanded, that are also being taken care of. So this is what we call as what we say in terms of capacity and functionality for a reconfigurable manufacturing system. Now, as in case of CNC, as in case of FMS, the primary motivators or primary enablers for FMS are the CNC machines. But when we talk of reconfigurable manufacturing systems, the primary ingredients or the helping components of, or what we call as the enablers of the reconfigurable manufacturing system are the reconfigurable machines. So generally, reconfigurable manufacturing machines, we can divide it into two areas. One is the capacity changing RMT. That means now, if say for example, if you just see this figure, these are the machines which are developed by a lab in US, Michigan. So earlier, what happened? You require say 2 holes. So this machine is basically drilling 2 holes simultaneously on 2 jobs. Now say I require more capacity, say 4 holes at a time. So I may attach 2 spindles again on these 2 provisions which are provided on the machine. So simultaneously 4 jobs can be catered. So I can increase my capacity. So this is, in very simple words, is a capacity changing RMT. Now functionality changing RMT. Say at one point of time, I want a hole at parallel to x-axis. At another point of time, I want a hole which is 90° to x-axis or on y-axis. So I must have an arrangement on my machine, so where I can get both the two. That is a hole which is in line with the x-axis, and another point of time I want a hole which is in line with the y-axis. So this is what we call as the functionality changing RMT. So these are some of the very early developments nowadays. Yes, any query? Okay, so this is some of the very primary inventions which are there as far as the reconfigurable manufacturing is concerned. Now, when we talk of the reconfigurability, it basically, when we say a system is having a high possibility of reconfiguration, it must have certain characteristics. What are these characteristics? Let us see some of these characteristics in very brief. So just to explain, there are certain characteristics. If my system is having these characteristics, I can say there is a more possibility of my system is that we can go for reconfiguration. So this tool, what I have depicted here, I have taken this from the research paper of Corin, and Corin is basically the what we call as a father of reconfigurable manufacturing. So these are some of the characteristics which my system must be having if I say my system is having a high degree of reconfiguration. And with these characteristics, I must have these objectives in my mind, that is low cost, rapid responsiveness, and high quality. If we build a system like this, then whatever I build, that will be termed as a system which is more close towards a reconfigurable manufacturing system. Now let us see what are these characteristics. Like scalability. When I talk of scalability simply means, I told you earlier as well, that today my capacity is say 10. At any point of time, I want my capacity be 20 per minute instead of 10 objects per minute. Now I want 20. So how this can be done? So the idea, this is what we call scalability, and this is not something new. We are witnessing this in many of our day-to-day life equipments, like this, the backpack which we are carrying. There are a lot of zippers. So sometimes you need to carry less number of books. So some zippers can be put on, so it will reduce the size. And once you want a large capacity, you open these zippers, your size or the capacity of your bag increases. So this is nothing, but this is what we call as scalability. Similar is the concept with the design of the vehicles. So we are having a bus. So if I want a scalable, then I may have, say, if I more number of passengers are moving from point 1 to point 2. So what I can do, I can have 2 buses. So this is also a kind of scaling, but this is I call horizontal scaling. And as far as the scaling here is concerned, say I want to increase capacity. So instead of 1 machine, I can buy 2. This is also scalability. But this is what we call as horizontal scaling. But as far as the RMS is concerned, we need vertical scaling. That on a single machine, on a single engine, you increase some of the components so that your machine output increases. So this is what we call as a vertical scaling. So this is what we mean by vertical scaling, that we have added a floor on this bus. A first floor is added on this bus, so I increase the capacity. So this is the basic idea behind scalability. So if my system is having such things where I can do this, or I can call this system as a scalable system. Convertibility. Okay. So the idea is somewhat very similar to what food processors we are having. So what we are having just a base where a motor is being fitted. Now, if on this motor, if you are using a chopper, it will giving you chopped vegetables. If you are using a grinding jar on it, it is basically giving you a kind of wet grinding or dry grinding, whatever you want. You put a large jar on it and you want a milkshake or a mango shake to be processed, the same thing can be done on the same machine. And if you want something for which you don't have any jar, you can purchase a new jar from the market and you can add on this jar in your library. So that new feature is added. So the motor is same, that will be used. Now you purchase a new jar, so new feature is added to your library or to your kitchen. So this is what we mean by convertibility. So this is what we mean by convertibility. So if whenever we talk of RMTs, they have this feature what we call as convertibility. Diagnosability. The concept is nowadays, if you see your vehicles, then a large interactive screen is appearing before the dashboard. Now, diagnosability, say something happens to your tire. So before happening, you must be knowing in advance what is going to happen. Say, yes, if a puncture is there, so a punctureless tire is you are using. So the thing is that this will indicate that your tire is having a nail inside it. So just move on and stop to the nearest repair shop, puncture repair shop, whatever you are having. So this is visible on your screen. So this is what we mean by diagnosability. So there are many such features which are now appearing in the devices which diagnose something in advance. Low air pressure. So a green changes to red, a green signal changes to red if your air pressure is low. So sitting on the car itself, you can monitor what changes are happening around your vehicle. Then motion visualization. Nowadays, you are having a vehicles where you are having a 3D view of whatever vehicles are moving around your vehicle. So this is what we mean by diagnosability. So the thing is that when we talk of RMTs and a reconfigurable manufacturing system, these features we have to build up. Okay. Customization. Okay. So customization, simply I say that uh, uh, within product A, say, for example, if I call this as a four-wheeler. So I want, if you just look at the market, then there is among the different variants, one variant which is nowadays common in almost every four-wheelers, that is option O or model O, SX, SXO, like this. So there is something model where O is appearing. O is optional. So optional doesn't means that whatever customization you want, that can be done. Okay, so that option is what we call as customization. So the thing is, this customization simply means that now my product, though I am making a shirt, earlier also I am making a shirt, but now the design of my shirt is changed. So how I can incorporate this design into my existing system? Because this is what we mean by customization. One person wants a product to be customized in his or her own way. Another person wants a product to be customized in his or her own way. We have to cater the both. So if we are having a system which is having such feature embedded into it, we say this is more close towards a reconfigurable manufacturing system. A single characteristic will not serve the purpose. Simultaneously, all these characteristics must be present in a system so that we can call this as a reconfigurable manufacturing system. Modularity. Modules. Module simply means plug and play. Earlier, what happened? We are purchasing a device which we want to use on our computer. Then what we need to do? We need to install a driver on it. Then some compatibility issues need to be checked. But if my system is modular, what I'm doing nowadays, you buy a pen drive, you just put it on a USB socket, it will start functioning. No need of any driver. Automatically, the driver will be updated, or whatever changes in the background is required, that is being done. Your RAM is malfunctioned, you just take out the RAM and you insert a new one. So earlier you are having a RAM 5 years old, and now you are purchasing a new RAM, but the same RAM will be inserted onto the slot provided for the RAM. So this is what you mean by modular. Switchboards. Earlier, what happened? We are using a mica sheet where holes are to be drilled, and we are using these switches on this, and they will be tightened by nuts, screws, and like this. But now what we are having a era of modular switches. You just insert it, it will be inserted into a plate, and you just put on the plate. That's all. So more, if we are having modular machines, like modular means, if we say a holding device is a module, an engine or a motor is a module, a flywheel is a module, and you just integrate it in terms of modules. So that if we are having a modular component structure, then the chances are that we can reconvert this into as per our need in a more efficient way. So this is what we mean by modularity. Integrability. Integration of one machine with the other. So the thing is that if I'm using this assembly line and say I want to insert a new machine into it, so how we can go for it? So if I am designing a system, I must take care that if some new machine is being added, so my arrangement should be capable of adapting the new machine in the system itself. So if here in this picture, if you see, S6 and S7 machines are being added. So some of the machines are removed and some new machines are being added. So this is what we call as the reconfiguration from MS1 to MS2. Similarly, I change the position of this machine. So this is again what we call as the reconfiguration 3. So this is what we mean by integrability. If I get something new reconfigured, then my existing system should be capable of accommodating the same. So that is what we mean by integrability. I have told you the compatibility issues. If there are compatibility issues, that means your system is not designed for integration. So today, nowadays, we are designing a system which have higher degree of integrability. So this is finally the comparison. And if you see what today, what we are talking of a system where we don't have any machines, specific machines on the shop floor. Rather, we must have only modules. And as per our need, I'm building upon a machine. And once the usage of this machine is over and I need to remodel or reassemble a new machine, that can be done with the help of existing modules. So that is the basic idea behind reconfigurable manufacturing systems. So these are the objectives and which we want to achieve. As far as the RMS is concerned, we need to have a system which is scalable. We want a system to have high degree of convertibility and adaptability, whatever changes are there in the market. Of course, with this we can only achieve if we build any system on these concepts. These concepts are modularity, integrability, and mobility. So if we build a system on these concepts, my objectives will be achieved. And as far as the operations is concerned, my RMS operation should have two features into it. One is diagnosability and other is the reconfigurability. So all these characteristics which we have discussed, it can be divided into three categories. One is basically related to operation side, one is related to the design side, and what we are achieving out of it. So this is all about what we call as a reconfigurable manufacturing system. I hope that in this short span of time, I must have communicated you some of the basics of reconfigurable manufacturing system, and at least I think I may have given you some insight about the reconfigurable manufacturing system. With this, I think I have uh, reached my scheduled time. Is it so, or still I have time?
Yes, sir. It is. It is about to complete
Okay.
actually.
Okay. So what I want, if you have any queries, then queries are welcome, and I will try to answer your queries.
Thank you, sir. Thank you so much, sir. Now, I requested all the participants. If anybody have any query, please go ahead and unmute yourself. Anybody have any queries?
Yes.
Please go ahead. I think, sir, nobody.
No
have
issue. No issue. My email is there. If anyone wants to contact me on this reconfigurable manufacturing system, then you may provide your participants with my email address. And
Yes.
once
Sir,
again,
Sir, I have an query. Like
Yeah,
if
sure.
we
Manjeet, please go
see
ahead.
machine tool industries in India,
Yeah.
in context of configuration and sustainability, what kind of scenario in
Yeah.
India this time, sir?
Actually, in India, even the flexibility is not been incorporated. Although the idea of flexibility was not a very new one, it was given around 20 or 25 years back. But we failed to adapt the flexible manufacturing systems. Now, the problem with India is that as far as the change is concerned, the big manufacturers, they can accommodate this change, but sometimes it's very difficult to ramp up the whole system, because the advantage of whether we talk of reconfigurable manufacturing system, or we talk of flexible manufacturing system, the returns which we get from out of these systems is not within a very short period of time. The impact of this change will be assessed over a period of time, and sometimes because of this what I can call the payback period is too high, there is a reluctancy among the manufacturers in investing in these kind of development. Rather, they go for purchasing new machines, buying new technology, instead of thinking of the reconfiguration. Although thinking of reconfiguration is a evolving process, and it requires a lot of calculation, that how is this reconfiguration can be facilitated. If the conversion of for reconfiguration time is high or the cost is high, then sometimes it's very difficult to answer whether we go for reconfiguration or we go for purchasing a new machine. So that is basically the scenario in India.
Thank you so much, sir.
Anybody else
No, sir,
have any query?
hello, sir. This is Guru Prasad, sir. Hello.
Yeah, hello.
Sir, this is Guru Prasad. I have one doubt, sir.
Yeah.
Sir,
Can
I
you
have one doubt,
yeah.
sir.
Yeah, please.
Sir, sir, this is the single minute exchange of die concept is done in the factories and all.
I'm not able to hear you. Can you just increase your voice a bit, your system voice a bit?
Sir, the single minute exchange of die is there, no? Some concept in the industry is there, no, sir? SME technique.
SME industries.
Single minute exchange of dies.
Yeah.
They will change the die in within 3 minutes or 1 minute, like that they are doing now, sir. The industries and all.
I'm not able to get you
sir?
what you are asking. Some voice problem is there. Please, can you repeat? Or if you write it in the chat box, I can answer it.
Just I will repeat one more time, sir. The single
minute, sure.
Single minute exchange of die concept being practiced in factories and all. Whether this will be applicable to our this particular presentation, sir?
Oh, the system, whatever,
something different.
No, whosoever is involved in manufacturing of anything. Of course, whenever we talk of manufacturing, we are talking of certain machines, certain components.
Okay,
so whenever we are having these things, we can think of reconfigurability. In a similar way, we think of flexibility. If we think of flexibility, then we can think of reconfigurability as well. Okay. So there is nothing which one can be excluded or one industry can be excluded. This is the concept which is not only applicable on the manufacturing side, but other factors like the support system. We can think of a reconfigurable support system as well. So one can think of its implementation to any kind of industry. This is not just limited to manufacturing or whatever. This we can think of because this philosophy can be implemented all across.
Okay, sir. Okay, sir. Okay. Thank you, sir. Thank you.
Well,
thank you, sir.
Welcome.
Now, anyone else have? Okay, I think now. So on the behalf of organizing committee, thank you, sir. Thank you so much for your valuable time and this wonderful lecture. Topic in this lecture is very useful in our day-to-day life, and also from this lecture you make us understand that how this configuration are useful to achieve our clean manufacture technology, sir. Thank you so much, sir.
My pleasure.
Yes. Now I request all the participants, please be there for 5 minutes. I just sending the attendance in the chat box. So please mark your attendance with the registered email ID only.
Okay, thanks a lot.
Sir.
Thank you very much. Thank you, organizers, and thank you. Thanks to all the participants for a patient hearing. And I'm accessible to anyone using my email ID. So that's all from my side. Thank you very much.
Thank you, sir. Thank you so much. Respected participant, I just posted the attendance link in the chat box. Kindly please mark your attendance with the registered email ID only. Again, I am repeating, please mark your attendance with the registered email ID only, as you email ID you registered with in AICTE portal. Please. Now I request you all, those who mark their attendance may leave this meeting.
Excuse me, sir. Can I ask the question for the host?
Yes, please.
Sir, anyone, any WhatsApp group also active for this FDP program?
Yes, sir.
Sir, can you please share the link? Because I have not
shared with your email ID, with the registered email ID. You may please check that email ID, please. Currently,
Okay,
I'm
sir.
not able to share with this.
Okay, sir. Okay. Thank you, sir. Thank you.